Now let's review the bending moment. So go in force and select beam diagram. I will choose step CS7 and for the component I will see MY, scale 1, contour, deform, you can take deform off, and legend. Click on apply, and now you view the bending moment at this particular stage of the analysis. So you can zoom on one specific part of the bridge. Now let's review the actual forces for, let's say, CS15 stage. So go in force, truss forces, and select CS summation, last step, okay. Now in the force filter select all, and I will view the legend, and you see the truss forces right now. So if you want to see the value, you can click here. So you have the value in each cables at a particular stage. So you can view like that the value of the truss force which is changing during the construction. Now I will review the deformed shape of the main girders and towers for each construction stage using the construction stage analysis graphs. So for each construction stage, we review horizontal displacement for the towers and vertical displacement for the main girder at the 1/4 of the point location of a side span. So this is in always result, and here you have a tab called stage and step graph. So define function displacement, add a new function, and can call it horizontal displacement, and node number 1, component dx, click on OK. Now define another function. This one will be vertical displacement. It will be at the node 27, where is the tower, and choose DZ for the component. Click on OK. Now the mode multifunction, because I've created two functions. The step option, okay, last step. Now check horizontal displacement and vertical displacement. Load case summation. Okay. Graph total will be horizontal and vertical displacement and vertical displacement for each construction stage. Graph, and now you will have the stage history graph for each construction stage. So it is giving you the change in vertical displacement and horizontal displacement during the construction. So it's a very important and very interesting graph. Now let's review the variation of the cable pre-stress by using the step history graph function. So just close this one, and here always this one. and define function. This time I will use truss force and stress. Add a new function, call it cable 10. Cable 10. The node is node 10. Force on, inode, and click on OK. Add another one called cable 11. So node 11. OK. Mode multifunction. Last step, x-axis. Unselect this one and select cable 11 and cable 10. Summation and graph. So this is the variation of the pre-stress in the cable during each construction stage. So you see that during the last construction stage there's a big variation into this cable. Now the last thing I will check is the variation in the bending moment for the main girder and towers. So this time I used the beam force and stress. I already created, so I will delete them and create them again. So choose beam force stress, add a new function. You can call it moment. You can call it moment of girder. Choose element number 45. Force on. Inode component moment in Y direction. Click on OK. Add another one, but for the moment of the tower. This time it will be at the node 108. Force on. Actual moment Y and OK. Now I just have to select these two functions here, summation, and can enter title bending moment of each construction stage and click on graph to obtain this bending moment. So the green one is the moment of the tower and the red one the moment in the girder at the specified node. Okay, it's the end of this tutorial. So thank you very much for following all this tutorial. I hope you will also follow me next week, because I will speak about the nonlinear time history analysis with isolators, which is a very interesting subject. So if you want to follow the next week's subject, don't forget to subscribe to my YouTube channel in order to view the video next week. Thank you again, and see you next week.